Hello students, in this lecture we will see how to calculate gain margin and phase margin from Bode plot and how to comment on the stability. Okay, so let's see. First of all, here procedure for gain margin is given. So gain margin calculation. Okay, see here actually I have shown one example with the magnitude and the phase plot. I told you that on same paper you have to draw magnitude plot and phase plot. So this is my semi-log paper. You can check that here x-axis is actually logarithmic axis for both magnitude and angle. So I have started with 0.1, next is 1, 10, 100. Same scale will be for phase plot also. On y-axis I will take m into b. So I am dividing semi-log paper in two parts. First part is for the magnitude and second part is for angle. Okay. Now here the important thing is that you need to draw the line with proper slope. Okay. So actually the magnitude plot is nothing but a line with slope. Okay. So see here I have shown this with line slope minus 20 dB per decade. You know that how to draw line slope minus 20 dB per decade. So when you will join 20 and first decade, so that line slope it will be always minus 20 dB per decade. Then you can check that suppose I will draw 40 and 1. So that line slope it will be minus 40 dB per decade. So here I have shown minus 40 dB per decade. Okay. For that I have used the roller scale. Okay. So what I will do when I am joining this 40 and 1, so I have extended that line. So the line slope it will be minus 40 dB per decade. Okay. And here I have shown the phase plot. Okay. Look at this. Here important thing is my reference line is actually minus 180 degree. Reference line is always minus 180 degree. Okay. So we will start with the procedure one by one. Look at this. Gain margin calculation. Number one. From phase plot, find omega where the phase curve crosses minus 180 degree. Okay, this is called phase crossover frequency omega PC. So I am just following step by step whatever it is given here. So from phase plot, look at this is phase plot. So from phase plot find omega where phase curve crosses frequency. Look at this, phase crosses minus 180 degree line. So this is my minus 180 degree line and this phase plot is intersecting with minus 180 degree line here. You can check that. Here it is intersecting. Okay. So I will get a frequency here because this is omega. Okay. So I will get a frequency and that will be the logarithmic frequency. So what I will say to that frequency? This is called as phase crossover frequency. Phase crossover frequency omega PC. So I will write here omega PC. Look at this. This will be my omega PC. When the phase plot is intersecting with minus 180 degree line, then that point of intersection is called as phase crossover frequency. Second step, draw a straight line from omega PC towards magnitude plot. Draw a straight line. Look at this. Now I got omega PC. So from omega PC, I will draw the straight line upward. I will draw the straight line upward so that it will intersect the magnitude plot. Okay. See here actually I have shown the line like this, but in actual Bode plot this line should be the faint line or it should be the dotted line. Okay. So that there should be the differentiation between the magnitude and the phase plot. So please draw this line as a dotted line or the faint line. Okay. So draw the straight line from omega PC towards the magnitude plot till it intersect magnitude. So this is my magnitude plot and it is intersected here. Okay. So find out the point of intersection G. So this is called as G. Okay. Then the difference between 0 dB and point of intersection is called as gain margin. So look at this. This point G is there and this is 0 dB line. Okay. See for this is actually 0 dB line. Okay. On y-axis the same point it will be reflected as 0 dB. So see the difference. This difference. Okay. This difference between 0 dB line and this point of intersection is called as gain margin. I hope you are getting. See, this is the difference, this point and this point. Okay, I will show with another color. So see here, this is the difference and this is my gain margin. Okay, so you can see we have calculated gain margin like this. Now next is actually the phase margin calculation. Okay, so look at this phase margin calculation. I will follow the steps one by one. Number one, from the magnitude curve, see the important thing for calculating gain margin, we have started with the phase curve. Okay, we have started with the phase curve. For calculating phase margin, we will start with the magnitude curve. Okay, so now I think you are getting why I told you to draw the magnitude and the phase plot on the same paper. So from the magnitude curve, find where the resultant crosses 0 dB. So look at this. Here actually this is magnitude plot and this magnitude plot is intersecting this line at this frequency, okay, or at this point. Okay, so this point is called as omega GC, that is gain crossover frequency. Again I am repeating, when the phase plot is intersecting minus 180 degree line, then that point of intersection is called as phase crossover frequency. And when magnitude plot is intersecting with 0 dB line, then that point is called as gain crossover frequency. So I hope you are getting here, magnitude plot is intersecting at omega is equal to 1. So omega GC is actually 1 here. Okay. Now second, draw a straight line downward. Okay. Now we will draw a straight line downward till it intersect phase plot. Okay. So look at this. I am drawing the straight line. This is my omega GC, and from omega GC I am drawing the dotted line, okay, where it will intersect. See, this is actually intersecting the phase plot here. Okay, so it is intersecting phase plot at this point. Then next find out the point of intersection between point P and minus 180 degree is phase margin. So this point is called as P, whereas here we have shown this point of intersection as G. Okay, this is point P suppose. Now what we will do, we will calculate the difference between this point P and minus 180 degree line. So look at this. Here I will calculate the difference between this. Okay, so again I will show this with the black pen. Okay, so look at this. Here you need to calculate this difference from point P to minus 180 degree line. So this is called as phase margin. Okay, so this difference is called as phase margin. Okay, so I hope you are getting the procedure for calculating gain margin and phase margin. So once you will calculate the gain margin and phase margin, now the important thing is you need to calculate or you need to comment on the stability. This is the only purpose of drawing the Bode plot. Okay, so look at this. Here I have written some conclusion. If both gain margin and phase margin are positive, system is stable. What is necessary condition for system to be stable? Gain margin and phase margin both should be positive. Okay, so I am underlining this. Please remember, for system to be stable, gain margin and phase margin both should be positive. But how we will know whether this gain margin and phase margin is positive or not? Okay, so see here I have written, when system is stable, omega GC is less than omega PC. Okay, gain crossover frequency is less than omega PC. Then in that case, gain margin, phase margin both will be positive. Okay, please remember this conclusion. Omega GC less than omega PC, then gain margin, phase margin positive. If gain margin is greater than phase margin, then not gain margin. If omega GC is greater than omega PC, then gain margin, phase margin both are negative. Okay. Next, if omega GC is equal to omega PC, okay, so gain margin is equal to 0, phase margin is equal to 0. So what you will say to that condition? Marginally stable. Okay, so it depends on the value of omega GC. If omega GC is less than omega PC, system is stable. If it is greater, then system is unstable. If these two values are equal, system is marginally stable. And what will be the case if this 0 dB line is not cutting the magnitude plot? Look at this. Here magnitude plot is intersecting with 0 dB line and we got omega GC. Or here also the phase plot is intersecting with minus 180 degree line. So we are in a position to calculate omega PC. But in some transfer function, it may possible that this magnitude plot is not intersecting with this 0 dB line, or it may possible that this phase plot is not intersecting with minus 180 degree line. So what will be the conclusion? If 0 dB line is not cutting the magnitude plot, then omega GC is infinite. If you are not in a position to calculate omega GC, so omega GC is infinite, so phase margin is infinite. Okay, so this is important conclusion. Then second conclusion, if minus 180 degree line is not cutting phase plot, if this phase plot is not intersecting with minus 180 degree line, then omega PC is infinite. If you are not in a position to calculate omega PC, then it is infinite, therefore gain margin is infinite. Okay, so now we will check the stability for the thing or for the example I have considered. Look at this, you can check that this is omega GC. Okay, so omega GC, you can check that this is point of intersection of magnitude plot with 0 dB line, and I got omega GC as 1 here. Okay, but you can check that here it may be possible that omega PC, this is actually omega PC, and you can check that if it is 1, so it may be 4 or 5. Okay, approximately it may be 4 or 5. Okay, so you can check that here omega PC, suppose I am getting as 4. Okay, so what will be your conclusion? Look at this, omega GC is less than omega PC. So what you will say? What you will say? Gain margin and phase margin both are positive. You can check that here when I am saying that phase margin is positive, so my intersection it will be always above minus 180 degree line, and when I am saying that gain margin is positive, so this difference it will be always below 0 dB line. It will be always below 0 dB line. Okay, so the conclusion is as omega GC is less than omega PC, so system is stable. Okay, system is stable, and in that case you will get gain margin as positive value and phase margin as positive value. Okay, so I hope you are getting in detail how to calculate the gain margin, phase margin, omega GC, omega PC. So in next class we will solve the numerical based on the Bode plot. Thank you, students.